This video is all about how to prove angle bisector triangle theorem, where the ratio of AD all over DC is equal to the ratio of AB all over BC. So now let's begin. Now let me just draw the triangle here. So this triangle now is being bisected by this line. Let's say you have A, B, C, and D. Then this B, D bisects this triangle, this angle here into angle theta. So now, and the ratio of AD all over DC is equal to the ratio of AB all over BC. Now, the first method to prove this equation. Now, let me now assume I draw a line along, I extend the line BC, then I now draw a line parallel to this line in such a way that this and this the value here and the value here is the same. So now since here is parallel to, since BD is parallel to, let me call this, they meet at the point E. Let's say AE is parallel to BD. So since if they are parallel and there is a common line here, that means angle A E sorry B A, let me clean this. Angle from this diagram, it shows that now this AE is parallel to BD. So if AE is parallel to BD, then angle BAE is equal to angle ABD. Now, angle AEB is equal to angle DBC. So this angle here is equal to this angle, which is theta. Now, from this expression, you will now notice that triangle CAE is similar to triangle BCD. So they are similar. So now, let me erase this thing. So from this diagram, since line AE is parallel to line BD, then angle AEB is equal to angle CBD. That means this angle here is theta. So from that expression, from this understanding, it now shows that triangle ACE is similar to triangle BCD. So since they are similar, we can now work with it. Now, since they are similar, we can now say from this diagram, we can now say that E ratio EC all over BC is equal to ratio AC all over DC. Now, EC is equal to EB plus BC, while AC is equal to AD plus BC. Also note that AB is equal to BE. Now, since AB is equal to AB is equal to BE, so this is BE or EB. Then that means we have AB plus BC equal to EC. So it now implies, now having, since we have gotten all that, I can call this equation 1. Okay, let's call this one equation 1, equation 2, equation 3. Now, we will now use equation 2 and 3. So we have gotten this. So now, so let me still write down the ratio again. EC, ratio EC all over BC is equal to, so now, if you look, EC from this bigger triangle, which are similar to this other smaller triangle, so B over BC, then AC all over DC. So now we have gotten from equation, this is equation 1. From equation 2, EC is equal to ABBC. So we change this to AB plus BC all over BC equal to AC is equal to AD plus DC. AD plus DC all over DC. So this one, the value, the expression at the right hand side can also be written as AB divided by BC plus BC divided by BC equal to, the right hand side can also be expressed as DC divided by AC divided by DC plus DC divided by DC. Now, you can see that this will cancel out this, because this divided this is 1. So you now have AB all over BC plus 1 equal to AD all over DC plus what? 1. Now, since you have 1 here, you have 1 here, so they will cancel out, cancel each other. Now we now have what we have left now will now be AB all over BC equal to AD all over DC. So, and that is what they want us to prove. AD all over DC, AB all over let's see, AB all over BC equal to this AD all over DC. So we have done that. Now let's look at the second method. Let's look at the second method. Now the second method, let me draw it here. You have it. Let me draw it here. You have a triangle being bisected here. You have A, B, C, D. So here is angle theta, here is angle theta. So we can extend a line like this. Now draw a line this other way, parallel to this one, this line. So parallel. Then this place is equal to this place. Now let's call this E. Now this angle here is equal to this angle. Let me call it alpha. Then since this angle is parallel to this angle, then this angle here, which is beta, is equal to this angle here, beta. Now let me just explain it. Now since BC, so BC is parallel to AE. Since BC is parallel to AE, it then means that angle CAE is equal to angle ACB. Now, if angle ACB is equal to this, so now then this one, angle A, here is D, ADE is equal to angle BDC. So if these angles are equal, now and also angle AED is equal to angle CBD. That is, this angle is equal to this angle. This is theta. So now it now means that triangle ADE is equal to triangle BCD. So if those triangles are similar, it then means that now the ratio AE all over, now here is beta. So if you see AE is adjacent to angle beta and theta. So which one is at this similar side? Which one is adjacent to angle beta and theta? Which is what? BC. Now this ratio will be equal to, now we'll now look at angle on this other triangle, because this other triangle is the one up here. So now angle AD, not angle now, AD is adjacent to beta and alpha. So which one is adjacent to beta and alpha in this other part of the triangle is DC. So divide by what? DC. So you see it. Now you also note that, note that note okay, say note that AE is equal to what? AB. So now if we now put AB up there, we say AB divided by BC, it will now be equal to AD divided by DC. So you see, it is proved again. Now let's look at the third method. The third method. Now the third method, we are going to use the sine rule. Now let's say this, you have A, B, C divided by line, bisected by line BD, bisecting this angle. Now using the sine rule, let's say here is equal to what? Alpha. And here, since it's angle on a straight line, here will now be 180 minus alpha. So now looking at in triangle ABD, using the sine rule, you now have AB all over AB is opposite to this angle, angle 180 minus theta. So it will be all over sine 180 minus alpha, which will now be equal to, this ratio is equal to AD divided by sine theta, because AD is opposite to angle theta. So AD divided by sine theta. Now let's now multiply both sides. But before I multiply both sides by a factor, I now have to look at coordinates. At the first coordinate, all is positive. At the second coordinate, only sign is positive. At the third coordinate, only tan is positive. At the fourth coordinate, only cos is positive. So now, if you look at this 180 minus alpha falls within this range. 180 minus alpha. So since sine is positive at the second quadrant, that means sine 180 minus alpha is equal to sine alpha. So we're going to rewrite this as, AB divided by sine alpha equal to AD divided by sine theta. Now, what we're going to do next, in order to move the trigonometric function one side and the length of the sides one side, what we're going to do now, we multiply both sides. What we're going to do is to multiply both sides by sine theta all over AB. Now, because we want to remove this one here, we also want to remove this one here. So we are going to use the inverse of them to multiply both sides. So now, we now also multiply this one by sine, by this same thing, because what you do to the right hand side, you also do it to the left hand side. So we multiply the left hand side by also the same value. So if we multiply the left hand side with this same value, this AB will cancel out here. Then sine will cancel out itself here. Now we are left with sine theta all over sine alpha equal to AD all over AB. Now we have gotten this. Let's call this equation 1. Then the next one, let's now look at the next one using the sine function. Let me just see if it could enter here. Then now let me see if it can enter here. Let's say triangle, in this other triangle, in triangle BCD. Now using the sine rule, you will now note that BC all over sine alpha, because this is the angle opposite to BC, is equal to, this ratio is equal to DC divided by sine theta, because sine theta is opposite to this DC. So that is it. Look at what we are using now. Let's go to the next page. We now have BC divided by sine alpha equal to DC divided by sine theta. Let me see whether it is, that is what we got. Okay, that is it. Now, what I will do next, in order to move the trigonometric one side and move the length of the sides one side. So now what I will do is, now I will multiply. Okay, let me just do it down here. Let me say, I'll say BC all over sine alpha. I will now say I will multiply this with sine theta divided by BC equal to DC all over sine theta times this same value here that I used to multiply both sides. So I will just use sine theta all over BC. So this sine theta will cancel out here, BC will cancel out here. You now have sine theta all over sine alpha equal to DC all over BC. So we have gotten, we'll call this equation 2. Now let me now say equating equation 1 and 2. So when you check, equation 1 and 2 are the same, because sine theta all over sine phi is the same thing here, sine theta all over sine phi. So that means AD all over AB is equal to DC all over BC. So now it now implies, now if you look at this whole thing, if you look at it now, the way the formula is being stated is, so now what we are looking at now, what we're looking at is to rearrange that so that it will look like the way the formula is. So now, but for us to do that, we are going to multiply both sides of the equation with a value. So now what we're going to do is, this AD divided by AB, we now multiply it both sides with a factor. And the factor we are going to use to multiply both sides is AB all over what? DC equal to, here now you have DC all over BC, which is the term on the left hand side. We'll now multiply with this same thing, AB all over DC. So we'll multiply both sides with this factor. So multiplying both sides with this factor, this AB will cancel itself here. You now have AD all over DC equal to this DC will cancel DC here. So now you now have AB all over BC. So if you check, the formula is also being proved here now again. Thank you for watching till the end. Have a nice day.